Today I'm going to show you our first topic is about engineering economy, and what I'm going to show you is an image that will depict all the engineering economy formula, everything. So all you need to do is to remember this image, and you will be able to remember all the engineering economy formula. This man is eating a bowl of pea soup, and we can call him Siri. Okay, Siri. Now, these are the formulas that you can derive from this image. First is the simple interest formula. As you are aware, this guy is eating. So, he's using his teeth. And in Filipino term, teeth means ipin. So, this is a simple interest formula. So, I is for interest amount, P is for principal amount, I is percent interest, and N is the number of years. It's a direct formula for simple interest. Now, if the engineering economy problem contains the word compounded, annually, quarterly, uh, semi-annually, bi-monthly, when you see the word compounded, that means you're going to use the compounded formula. So this is not as simple as about the teeth or ipin. It's about the whole image of this of the guy named Suri, who is in love with the registered nurse. Alright. So if you will look at this image, A is the tummy part. So it's an accumulated amount. A, and this is a bowl of soup, no? And he's eating using a spoon, which is P, and then his mouth is eating is 1, his nose is plus, and his eyes are RN. As I've said, his eyes only belongs to nurses, registered nurse. And then this is his brain, the nut. So this depicts this formula of the compound formula interest, which is A is equal to P, open and close parenthesis, 1 plus R over N raised to N times T, where A is the accumulated amount, P is the present award, R is the compounded interest, N is equal to number of terms, T is the time in years. So if you want an example, this is how you draw it, right? P is the present amount of the money, and A is the accumulated amount at the end of the term. R is, say for example, 15% compounded quarterly. So if I will write this, A is equal to present worth times 1 plus 0.15, the percentage rate in decimal, divided by 4 because this is quarterly, and then the total number of terms is NT, 4 times the number of years, which is 5. So 20. This is how you're going to represent the formula. So I just want to emphasize, this is A, this is P, this is the mouth, the nose, the eyes, and raised to NT, the nut. Pause. And the third formula that you can derive from this equation, you remember this, A is equal to P, open and close parenthesis, 1 plus R over N raised to NT, is the effective rate of interest formula. All you need to do is to imagine this term minus 1. The same term minus 1. So when the problem asks you about the effective rate of interest, you just need to remember this term here minus 1. Okay? So this is the formula for effective rate of interest. And to continue, the fourth formula that you can derive from this image is the annuity formula. You remember the effective rate of interest, which is cos n minus 1 plus R over N raised to NT minus 1. Now this term, multiplied by the regular payment in an annuity, divided by the annuity interest, you'll be able to solve the accumulated, the sum of all this annuity at a certain rate, time. Okay? So this is annuity formula. All you need to remember is series. S is equal to ER times regular payment over the annuity interest formula. Okay? Now, if you want to solve the perpetuity formula, you just assume that ER is 1. So now you will solve the perpetuity formula, which is the regular payment divided by I. Which means the regular payment is under perpetuity. It's forever, infinite. So R over I. Because ER approaches to 1. So this is the fourth formula, the annuity. Now to wrap it up, uh, from this image, I was able to extract 5 formulas, right? This image is a man eating a pea soup, a bowl of pea soup, a man who is in love with registered nurse. So his eyes belongs only to RN. So the simple interest formula from the word ipin or teeth, because he's eating. Now the rest are more compound, no? Compound interest formula, which is accumulated amount is equal to principal amount, open and close parenthesis, 1 plus the interest rate over a compounded terms times the terms multiplied by the number of years, and then raised to that value, raised to NT. Then the effective rate of interest is this term minus 1. So that's the ER, effective rate of interest. The annuity formula, which is SERI. The sum or accumulated is equal to ER, this term, times the regular payment divided by the interest. And to calculate the perpetuity, this ER approaches to 1, so that's regular payment divided by the interest. If you like this video and you want me to pursue further, just subscribe.